Muhammad Abdullah, Muhammad Ahmad. You have written this example questions.
No, sir.
व्हाट्सएप पे भेजे ना, लिखे नहीं आप लोगों ने? Okay, write down these questions. There are two parallel plates at a distance. Screen is visible
Yes, sir.
at a distance of 0.6 mm, and the gap is gap is filled with oil of viscosity oil of viscosity 1.5 Newton second per meter square. The upper plate is moving. The upper plate is moving 3 meter per second to the right. To the right. Right means right side. To the right. To the right. And the lower plate. And the lower plate. The lower plate is at rest. Yani the velocity of lower plate is zero. It means that at rest means the velocity of find the force, find the force and power required power required power required to maintain to maintain speed of upper plate, to maintain the speed of upper plate. Okay, the speed should not be changed. It means that take the area of plate, take area of plate is 0.5 meter square. So this is our example. There are two parallel plates at a distance of zero point 0.6 mm, and the gap between the two plates are filled with the oil of viscosity 1.5 Newton second per meter square. And viscosity, dynamic viscosity is given. The mu value you can say. Okay? And the upper plate moving with a speed of 3 meter per second to right, and lower plate is at rest. Find the force and power required. Find the force and power required to maintain speed of the upper plate. Take area that is 0.5 meter square. So we will draw this. I will draw the upper plate. This is the plate. Okay, and this is moving toward the right with the velocity and the power. Okay, and this is the force F. The force F, and it is a distance of 0.6 meter. This is the H, distant apart, and the viscosity, if you say it is mu, write down the mu, is the viscosity of the fluid of the fluid. This is the fluid. Okay, and it is saying oil of viscosity. So what is given? The given in data given. I'll write on the solution. So what is data given? The data given are, we write down here, page number 4. Data given. H is given, that is 0.6 mm. If I convert in meter, because all the quantities we will write in meter, 0.6 into 10 raised to minus 3 meter. So that mm we convert in the meter. And the velocity mu of, it is also given 1.5 Newton second per meter square. Velocity, it is mu, viscosity mu. Also the velocity of the plate is 3 meter per second, and area of plate is also given, A is 0.5 meter square. So these are given in also. First you have to draw this figure so that you understand the problem. Okay, so you understand the problem. The velocity V and P, that is power, they are the driving force of the plate. F is the opposite force trying to resist due to the viscosity of the oil, and the velocity gradient, if you write down, you find out first the velocity gradient. The velocity gradient generally we are denoting it by V upon H. H is the head. So this is 3 meter per second is divided by 0.6 into 10 raised to minus 3. It will be, so it is nothing but velocity gradient means change in velocity with respect to the head. So initial velocity is 0, so it is 3 minus 0 is 3. So it is, if you solve, it is coming 5 into 10 raised to 3 per second. The velocity gradient is 5 into 10 raised to 3 per second. That is due by. Now we know the Newton's law of viscosity. So using Newton's law of viscosity. What is Newton's law of viscosity? We have seen earlier, that is tau. It is equal to mu time du by dy. du by dy. And we know that mu is 1.5 Newton second per meter square, and this is 5 into 10 raised to 3 per second. So tau will be, if you solve, it will be 7.5 into 10 raised to 3. If you multiply 1.5 into 5, it is 7.5 into 10 raised to power 3, and Newton per meter, because second or per second it will cancel. So Newton per meter square, this will be the tau, that is shear stress. Or we know that tau is nothing but upon force upon area, है ना. हमको बेसिक फार्मूला स्ट्रेस का मालूम है, P upon A. Load upon area is nothing but the stress. So here stress, shear stress is there. Shear stress we are denoting by tau, that is force upon area. And here we don't know the force, we have to calculate the force first. So if we want to force is equal to tau, then shear stress into area. So shear stress is 7.5 into 10 raised to 3 and area is 0.5 meter square. So if you solve this, the force is equal to, if you write down, tau into A, tau is 7.5 into 10 raised to power 3, and area it is given in example 0.5 meter square. To multiply or divided by 2, multiply by 0.5 or divided by 2, the force will be 3750 Newton. So this is our first solution. In second solution, we have to find out the power. And power we are generally measuring into watt. So it is generally, power is nothing but force into velocity. Power is nothing but force into velocity. Because unit वाट का अगर हम यूनिट देखेंगे, पावर का यूनिट पहले मैंने बताया आपको, इट इज न्यूटन मीटर पर सेकंड. न्यूटन मीटर पर सेकंड. So Newton is nothing but your force, meter per second is nothing but your force. So power is nothing but force upon velocity, and already we have calculated the force. It is 3750, and velocity to maintain the speed of the upper plate, that is 3 meter per second. If you multiply this by 3, so 303, 3 5 15, 5, 3 7 14. This is 11,250 Newton meter per second will be the power to maintain the 3 km velocity, or you can write down 11,250 watt. 11,250 watt. So this is the solution of our first example. This is the solution of our first example. Okay? तो ये सब मेरे ख्याल से सबको समझ में आ गया होगा. How to calculate the power and the force. Okay? So if you this direction, you don't go on the direction. Force is the driving force, and the problem, when you solve, first try to analyze the problem and try to make a figure so that it is easy for you to solve the example. Then you have to write down the data given, and then you have to find out step by step what is required. So du by dy is nothing but the velocity gradient, and velocity gradient is nothing but velocity divided by change in velocity divided by h. So h is the two plates having a distance apart 0.6 mm. So that's why I have written in meter, 0.6 to 10⁻³ meter. Okay, we get the value of du by dy, that is 5 into 10⁻³ per second. Okay, so here your viscosity is Newton second per meter square. Viscosity is Newton second per meter square, and this value you find out per second. So this second will cancel, and this Newton per meter square will be remain. And you know that the stress, any stress, it is nothing but force upon area or load upon area. So here force is there. Force upon area is nothing but tau, And tau we know, we don't know the force. That's why we have taken left side the force value. The area will come here right side. So this tau into area. So if you multiply tau into area, you will get the force. Okay, and then you can find out the power. Power is nothing but in watt. It is Newton meter per second. Newton is nothing but force. Force into velocity is nothing but power. Multiply with the velocity, which has to be maintained at that force. So we have to maintain the velocity of 3 meter per second. Uh, so, so 3 meter per second into the force, you will get the power required to maintain the velocity of 3 meter per second. So this is the power P in watt. Okay. So likewise, you have to solve the example. I will solve the second example, but we have very little bit time. So just you will go through the these formulas. I have given this sheet already. I have shared with you. So you should able to find out on the basic units. So you can find out the dimension and the basic units of that. Okay. So we will stop here, and the next example will solve next day, or I will send you the message. Okay, any question, any doubt you can ask, or otherwise we will stop here. हेलो, समझ में आया एग्जाम्पल सबको?
Yes, sir.
Yes, sir.